So we talk about elements, and we said that elements can be broken down into new substances, and that's correct. But we can actually break the element down to its atomic level. Then we get this thing called the atom. What makes something an atom?
I think the ball thing is outside.
Yeah, that's kind of the ball thing, yes. And when we come up here, I actually have a model of a silica molecule, or silica compound rather than molecule, because it takes two of those. Okay, this is what we call a tetrahedron. So this is silica. Silica is 4 oxygen in 1 silica. So the yellows are the oxygen atoms, and then in the middle is the silicon atom. So together this is silica, SiO4. Now, silica is really important because it makes up the building blocks of all of our minerals. Okay, the majority of our minerals, over 85% of the minerals on Earth, are made out of silica. So really, really important compound to know. But like Tom was saying, is that the ball thing? Yes, when we think about these, we model them with these spheres, and that's your atom. A good way of looking at an atom is basically it's the smallest piece that retains the property of the element. And that's a good way of thinking about an atom. It is the smallest particle that retains the properties of the element. Now there are 3 things that make up an atom. We call these subatomic particles. Now I'm going to test your obviousness, your awareness for things around you. What are the 3 subatomic particles? Say it louder, Bree.
What?
Protons, neutrons, and electrons. Okay, protons have a charge. What's their charge?
Positive.
Positive. Electrons have a charge. What is it? Negative. And the neutrons have a charge, but they actually don't have a charge because they're neutral. They don't actually have a charge. Okay. So a couple of things to mention here. Where would I find protons and neutrons? Where in the atom would I find those? No.
In the middle.
What do we call that middle piece?
The nucleus.
The nucleus. Good job, Akira. Those are found in our nucleus. And they're just kind of jumbled in there all together. And so, kind of thing like that. We only have a bunch of protons all scattered throughout here in my nucleus. And then in the open spaces, I then fill that in with all my neutrons. All right, so we get this. And then, because these things are just spinning around, that's why we get this kind of spherical look to the center of the atom. Okay, just a whole bunch of protons and neutrons all squished together. And then where do the electrons go?
They spin.
Yeah, they go on these rings, right? Think of it like almost like the planetary rings around the sun. Okay, so remember we talk about models, we talk about scale. Another way of looking at an atom is basically it's our universe on a very, very, very small scale. Same concept. Or you can think of it as the atom is really just a small model of our entire universe. So it's just these things that you have this very massive piece in the middle and all these really light things surrounding it, and they're held in orbit. Okay, so we have these things that are called, each one of these is called an electron shell. What's important for you to understand is that in the electron shell, these can keep going out forever and ever and ever. But the first shell has how many electrons in it?
3.
It only has 2 electrons in it. That's important for you to know. Guys, listen to me. It is important for you to know that the first shell has only 2 electrons in it. What does the next shell have? Bless you. Next shell has 8. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. What about the next shell after that?
16.
Nope.
18.
We have 8 again.
Oh.
But Tom, if I were to go one more shell, how many would I have then? 18. Yeah, you're like, okay, where do you come up with these numbers, right? We'll talk about that later today. Okay. It's actually really easy to know. Tomorrow we're going to spend more detail on the periodic table. We're going to kind of use it a little bit today, but it's actually really useful to actually know how to use the periodic table. So, anyways, that's how we know how many electrons are in each shell. If you think about the first row of the periodic table, there's only 2 elements. Therefore, 2 electrons. If you go to the next row of the periodic table, there's 8 elements in that row. If you go to the third row, there's 8 elements in the third row. If you go to the fourth row, also we move up to 18 elements. Therefore, there's a total of 18 electrons in that next shell. So that's a really easy way to identify how many electrons are in each shell.